Okay guys, I have to apologize for the page may move a little because I've got this contraption that's holding this up with some weights and some string, and there's a couple of cats involved in it, so anyway, if it moves, just forgive me. So last week we covered conductivity and conductance, and we used this table 3-3 with the heat transfer coefficients of building materials. In my train book it's page 365, in yours it may be on another page, but at any rate it's table 3-3. And it has different building materials over here, and then in each one of these categories there are a bunch of subcategories which are the actual materials themselves. And this column is K numbers, which is conductivity, and this column of numbers is C, or conductance numbers. You remember that conductivity, the K number, is just a number. It doesn't have any thickness related to it. So it's just a number for material with no thickness. C numbers, on the other hand, are the material to a certain thickness. Obviously a material has to have some thickness to it, so the K numbers don't do us any good unless we know what the thickness of the material is. So for instance, here in building boards, it says plywood has a K number of 0.8 and a C number of 1.07. Now the C number is for 3/4 inch plywood. The K number is just for plywood, no thickness applied to it. So if we take this K number, and remember K over X, K number, divided by the thickness equals C. And we'll prove it here. 0.8 divided by 0.34, divided by 0.34, divided by 0.75, which is 3/4 of an inch, that's where the 3/4 came from, equals 1.07. So plywood of this K number divided by 3/4 of an inch, which is what this was, comes out with that C number. So whatever the material is, if you can divide it by the thickness, have the K number divided by the thickness, you will get the C number. Okay? Good. I'm going to give you a couple more letters. And the first letter is R. And R stands for resistance, or resistance to heat flow. And we use R numbers when we're using composite walls. Last week we did homogeneous walls. This week we're doing composite walls. So R equals 1 over C. Okay? So for instance, in this plywood example that I used here, 1 over 1.07, I have my calculator right here, 1 divided by 1.07 is 0.93. So for this 3/4 inch plywood, the R number is 0.93. The reason I want you to know these R numbers is the assignment that I have on Blackboard right now is for these different wall constructions, and here's a full list of all the materials that make up those wall constructions. Over here I've got some other information and information about the building. I'm not worried about that right now. That's another assignment. For right now, all I want you to do is get all of the R numbers for all of these composite materials, these components that make up this whole wall, come up with a total resistance, so add all those up, get a total number, and then I want to take that R total, take the reciprocal of it, and that equals U, and U is the overall resistance of the composite wall. Okay? Good so far. Now what I need to do is look at some of the peculiar parts of these building materials. And one that we talked about last week was this 3/4 inch airspace in this particular wall. And if you will look in your train manuals, and by the way, if you don't have your train manual, you better get your butt in gear and get over there and get it. all right, or off Amazon or wherever. I don't care where. Just get that thing. For air spaces in a wall between ordinary building materials having a thickness between 3/4 and 4 inches thick, and ours is 3.5, so we fit in here, the approximate C number is going to be 0.48. Okay? 0.48. So this airspace in between here does provide some insulation, some insulating effect. And in this case, it's going to be 0.48. So C equals 0.48. If I want the R number for this, R equals 1 over C, which equals 1 over 0.48. And I got my calculator here. I'm doing it divided by 0.48 equals roughly 2.1. So the R is 2.1. For this airspace here, this 3.5, for the R number, I'm going to put 2.1. Okay? So that airspace is one thing that we need to take into consideration. Also notice that it has an outside air film and an inside air film. All walls have this air film on either side of it, and that acts as an insulating component as well. So if I flip this page 22 over and I look over here, the surface conductance of building materials depends upon the color and smoothness of the surface. The average value for popular materials for still air, and usually on the inside wall we're going to call that still air, we're going to use 1.63. So the C number for inside air is 1.63. For the outside, we're going to use this worst case, which is 15-mile-an-hour wind blowing against the wall. That's going to remove some of the air film, so it's going to reduce the insulating value, which is, we'd rather have it, we'd rather over-engineer to make sure we have enough capacity than under-engineer. So we're going to use 6 as our C number. So let's look at that. For inside air film, C equals 1.63. I'm going to move this down here, so 1 over C equals the R number for that, and that would be 1 over 1.63. Let's do that. 1 divided by 1.63 is 0.63. So the R number for this inside air film is right there. Okay? Not much insulating value, right? Remembering that big R numbers means a lot of insulation, and small R numbers is not very much insulation. Let's do the outside air film. And by the way, for all of the ones all the wall constructions that we do, there will always be an inside air film, there will always be an outside air film, and when we're using an outside air film, we're always going to use this 6 number air film. C equals 6.0. So 1 over C equals the R number, and that equals 1 over 6.0, which is, clear that, 1 divided by, whoops, clear that, 1 divided by 6 is 0.16. So this R number, compared to that R number, you can see that this inside air film that still has much more insulating effect, resistance to heat flow, than the outside air film. And that makes sense, right? You got more air blowing over it. That means the air film is squished down. There's not as much insulating value there. Okay? So when you do this assignment, all I'm interested in right now is getting all the R numbers and a total, all the R numbers and a total, all the R numbers and a total. By the way, you'll notice here that it's inside air film, inside air film. This must be an inside wall that's separating 2 spaces. So we're not worried about the outside air film. There is no outside air film. This is just air separation between an interior wall. Get the total R's. And here's one more letter for you, and that is U. U equals 1 over R total. So the overall resistance to heat flow for this composite wall is going to be the U number. And the way we're going to get there is find all the R's, get the total, and then take the reciprocal of the R total to get the U number. Okay? I know it's a lot of letters, I know it's a lot of numbers, but fight your way through this, get the total R, take the reciprocal of that, 1 over that R total, and that gives you the U. Right there. Okay? All right, good luck. I'll see you next week. We'll knock this dead and we'll start moving on to actually doing some load calcs with different kinds of buildings, different wall constructions, and a little bit of that, and then we'll move into the computer stuff. Okie doke. Very good. We'll see you next week.